Welcome to Precalculus Concept 15C, solving a polynomial equation. There's only two boxes, but not going to lie to you here, guys. These problems are pretty involved, so I hashtag them as super gnarly problem. Okay, so I'm going to do two examples with you, and please sort of take some notes, follow along, and let me know if you have questions in the video later. Okay, so example 1, we are going to solve the polynomial equation x to the fourth minus 6x squared minus 8x plus 24 is equal to 0. Okay, we have a fourth degree polynomial. We would normally try and factor by grouping, but factoring by grouping is not going to work for us in this case because it doesn't group nicely. So what we do is we need to begin the process like we always have before, and the first thing is we're going to get our potential list of potential rational zeros. So I'm going to take the number 24 and list out all the zeros. So I can have plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Did I miss any? I think that's all of them. Divided by plus or minus 1. So that means I have 1, 2, 3, 4, 5, 6, 7, 8. If I double that, then I have 16 total things to check. This is a lot of things to check. So what we're going to do is we're going to graph this, and we're going to look for a potential rational zero. So here's what I have for you over here. So in Desmos, if I turn this on, this is the equation that I've already preset for you. And if I take a look at this, I can see that what I want is where this graph actually hits. And if I get in a little bit closer, I can see that 2 is a 0. But you should be noticing something else, everybody. You should notice that this graph only hits at 2 and then turns around, right? But we know that this thing can have up to 4 zeros, so where the heck are the rest of them? They must be imaginary, and that's what we're going to explore today. And also notice that this point over here is 24, which makes sense because the y-intercept, of course, is up there at 24. So I'm betting 2 is going to work, okay? So I'm going to go back to my notes, and I'm going to try to use 2 and then use synthetic division, okay? So keep in mind, I'm going to have a 1 here. I have no x to the third term, so I'm going to have a 0. I'm going to have a negative 6. I'm going to have a negative 8. And I'm going to have a positive 24. Skip a line and draw a line. Bring this down. This is going to be 1, and I'm going to add. 1 times 2 is 2. 0 and 2 together make 2. 2 times 2 is 4. Negative 6 plus a 4 is worth negative 2. Negative 2 times 2 is worth negative 4. Negative 8 and negative 4 is worth negative 12. Multiplied by 2 is negative 24. Hey, look at that, and I get a 0 out of this. Perfect. So here's my remainder, here's my constant, here's my x squared, and here's my x to the third. So far, I now have this. I have x to the third plus 2x squared minus 2x minus 12, and I'm trying to find the zeros from this particular leftover sort of depressed equation here. Okay, so now you may be wondering, well, this is not a quadratic, so what do we do now? Well, basically, you guys, we just start the process over again. So I take a look at the factors of 12, and I divide those by the factors of 1. So all the factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12, all divided by plus or minus 1. We saw from the graph, from this particular graph over here in this picture, that 2 has multiplicity of 2. It's a double root, which means it's going to happen twice. So I can use that information again, and I'm going to bet that 2 is going to give me another 0 out of this one. So if I check 2, and I would get a 1, a 2, a negative 2, and a negative 12. So again, do synthetic division again. So bring the 1 down. 1 times 2 is 2. Add, I get 4. 4 times 2 is 8. Add, I would get 6. 6 times 2 is 12. Hey, look at that, and I get 0. So here's my constant, here's my remainder. Here's my constant, here's my x, and here's my x squared term. So from here, I can clearly see now that I have an x squared plus a 4x plus a 6. And now I'm in happy land because I have a quadratic. Even though I can't factor this thing, I know I can use the quadratic formula. So step number 1, the value of A is going to be 1, the value of B is going to be 4, and the value of C is going to be 6. Step number 2, I'm going to get B squared minus 4AC. So I'm going to take 4 squared minus 4 times 1 times 6. 4 squared is worth 16. 16, and then 6 times 4 is negative 24. So moving right along, I get negative 8 out of this thing, and which makes total sense because I'm expecting it to be a negative. So x would be negative 4 plus or minus the square root of negative 8 all over 2. So my solutions are going to be negative 4 plus or minus, if I take care of this, this is going to be 2I rad 2 over 2. Factor out a 2 from the numerator. So that would leave me with negative 2 plus or minus I root 2 over 2. Cancel my 2's, and therefore I would get the answer that x would be negative 2 plus or minus I rad 2. Okay guys, so when I'm all said and done, so all of my zeros are here. So my zeros are x equals 2, x equals negative 2 plus I rad 2, and x equals negative 2 minus I rad 2. This 0 has a multiplicity of 2 because it occurs twice, and each of the other ones have multiplicity 1. So that's what we're doing, that's where we're going. Kind of gnarly, not going to lie to you, but hopefully that made some sense. Okay, here we go. Box number 2, another example of the same kind of thing. Look at this gnarly thing. Holy cow. They want us to solve this thing. Alright, so let's start by making our list. So the first thing we're going to do, let's do, take the number 13. So it's either plus or minus 1 or plus or minus 13. Those are the only factors, all divided by a plus or minus 1. So my list is going to just be plus or minus 1 or plus or minus 13. That's only 4 things to check. I'm going to speed the process up by looking at the graph of this. So I'm going to go to Desmos, and I'm going to punch this in like I have here, x to the 4th minus 6x to the 3rd, 22x squared. So I'm going to graph this, and I can see that 13, of course, is the y-intercept. And I'm looking like there is a rational 0 at 1. And since the graph turns around at 1, it must have an even multiplicity, so that means I can use the 0 of a 1 more than one time. So I'm going to go back to my notes, and I'm going to go ahead and verify that 1 is indeed a 0. Okay, so use synthetic division. So set this up, I'd have a 1, I'd have a negative 6, I would have a 22, I would have a negative 30, and I would have a positive 13. So I've got 4, 3, 2, 1, and then 0, so everything is in order. Okay, skip a line and draw a line. 1 times 1 is 1. This would be negative 5. Negative 5 times 1 is negative 5. And I keep going. 17. 17 times 1 is 17. Negative 30 and 17 gives me a negative 13. Hey, look at that, negative 13. Of course I get a 0. Beautiful. So here's my remainder, here's my constant, here's my x squared, and here's my x to the 3rd. So I'm get this result. I get x to the 3rd minus 5x squared plus 17x minus 13. Now since 1 was a double root, meaning that the graph turns around, I can use the 1 again because I know that it turns around. So I'm going to use 1 again and do synthetic division on my new polynomial. So I'd have a 1, a negative 5, a 17, and a negative 13. Skip a line and draw a line. So give me 1. Let's add everything up. This is worth 1. This is going to give me negative 4. So this is going to give me negative 4 right there. This is going to be positive 13. Hey, look at that. A 13 and then a 0. So now I am left with x squared minus 4x plus 13 is equal to 0. And from here, I know what to do. I use the quadratic formula. So a is worth 1, b is worth negative 4, and c is worth 13. b squared minus 4ac is going to give me negative 4 all squared minus 4 times 1 times 13. So that's going to give me 16 minus, I'm going to have 4 times 13, 52, and 16 minus 52 is worth negative 36. So then x is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. So x is going to be 4 plus or minus the square root of negative 36 all over 2, which gives me 4 plus or minus 6i over 2, which factor out a 2 from the top. So I'd get 2 plus or minus 3i over 2. 2's cancel. So therefore, all of my zeros, the answer to this thing, how do we answer this? The zeros are x equals 1, and that happens twice, and then x equals 2 plus 3i, and x equals 2 minus 3i. So we're going to be doing lots of practice with this, but this is a very long process. Sorry for it, but I hope that it made sense to you.